Hello and welcome. We are Team Compositive, representing Virginia Tech. Every year, approximately 2 billion metric tons of solid municipal waste are produced worldwide. The World Bank projects that by the year 2050, this figure will have increased by 70%. Finding sustainable solutions to society's waste problem is now a high priority in the public conscience. For the 2020 Solar Decathlon Design Competition, we are excited to work with a client that is setting the gold standard for contemporary waste management in our home state of Virginia. The Prince William County Landfill, officially designated as an extraordinary environmental enterprise, is pushing the bounds of recycling technology, landfill gas harvesting, cogeneration, and much more. Now, the county desires a new building for their administrative staff that doubles as a nexus for STEM education and community engagement. This is where we, Team Compositive, propose the Eco Park Learning Center.
But first, a bit about us. Our team name Compositive is a composite of words sharing the same prefix, such as comfort, community, and complexity. The prefix com means together, and the word positive expresses our optimistic attitude that we bring to the design challenges. Compositive means that we are with positivity. Our Compositive team is a diverse group of students with majors ranging from architecture and building construction to macromolecular science and civil engineering. We have 7 graduate students and 21 undergraduate students working in collaboration to enrich the knowledge of every member on the team. We divided our team into 5 sub-teams, focusing on the topics of architecture, landscape architecture, marketing, engineering, and real estate, where sub-team leaders coordinated the work efforts conducted by each individual sub-team leader. Our student team lead is Dominic DeLeon, and our faculty advisors are Georg Reichard and Robert Dene. The students leading this presentation today include...
Hi, I'm Dom, a graduate student majoring in building construction, and I'm the student team lead.
Hey Dom, I'm Alex. I'm a junior of landscape architecture, and I'm the landscape sub-team lead.
Hey guys, I'm Mitch. I'm a senior in building construction, and I'm the engineering team lead.
What's up? I'm Justin. I'm a senior in building construction and real estate, and I'm the real estate team lead.
Hey Justin, I'm Sharavi. I'm a senior double major with architecture and building construction, and I was the marketing team lead.
Our 2 main industry partners are DPR Construction, who built their headquarters as a net zero office building, and Horgan Construction, who built one of the first Living Building Challenge certified buildings. Both have been instrumental in ensuring the constructability and financial attainability of our design.
The Eco Park Learning Center is a combination community center, office building, education resource and research center built to showcase the cutting edge of sustainable building technology. Preliminary design began as an independent studio project at Virginia Tech 2 years ago. Building on that first design proposal, our team took inspiration from the 7 petals of the Living Building Challenge, an ethic that we carry forward in an effort to establish the Eco Park Learning Center as the gold standard for environmental and community stewardship near the nation's capital. We employed a cyclical design process for developing this project. Each new design proposal was informed by engineering analyses and budgeting breakdowns. Iterating through this cycle allowed us to produce effective innovations, pushing the envelope of construction practice while ensuring financial feasibility. Our design for the Eco Park Learning Center was guided by 4 overarching design goals. First, an emphasis on conservation by activating existing ecology using reclaimed materials and utilizing iTree tools to identify the best trees to preserve. Second, a focus on community engagement by accommodating local school groups and universities, hosting community events, and providing park-like amenities. Third, a commitment to occupant comfort by planning for individual thermal zones, low-velocity HVAC systems, and biophilic lighting and material selection. And finally, the integration of cost awareness by including concepts of intelligent constructability, finding financially attainable solutions, and maintaining low operational costs.
Architectural design is where the play of form and function come together. We strove to build the narrative of EcoPark into every piece of the composition. To begin, the boundaries of our building lot do not mark the physical extent of our design vision. We believe in fitting architecture to place. To this end, we have provided our client with a vision that links the Learning Center to 3 public schools through educational trails. These features fold into the place pedal of the Living Building Challenge by contributing to a more pedestrian-oriented community. A constructed wetland borders our building to the east, which is explored with a boardwalk and educational engagement stations. More trails link to innovative landfill facilities and native woodlands. The EcoPark Learning Center is nestled into a forested area, perched on a hill on the western edge of the landfill property. The building form is conceived to merge the architecture with the landscape and create a strong visual relationship with the landfill.
The view of the landfill will change as the mound grows over time, offering a strong point of reflection for residents of the building. Visitors who arrive at the EcoPark Learning Center are initially greeted by a building that isn't there. On approach, a large grassy hill is revealed to be a green roof, and visitors spill into the welcome plaza, where a river of recycled glass leads to the front entrance. Passing through the lobby reveals a central courtyard, framed by the building's wings. The architecture flares open toward the continually morphing view of the landscape, which will change over the next decade from a theatrical industrial landscape to pastoral grassy hills. Creative space planning allows for community, academic, and office spaces to coexist. Accessible community spaces in the southern wing can accommodate gatherings and conferences. Research lab space on the first floor allows the Learning Center to expand its reach with live-in residence programs with state universities. Educational space takes the form of multi-purpose classrooms on the first floor, tailored to STEM education. Finally, office space is located partially on the first floor and covers the entire second floor. Separate areas for closed office space are allocated for municipal staff, and rentable open office space is available for tenants. Rentable offices are further divided between the first and second floors to mitigate issues pertaining to noise and privacy. Office amenities include kitchenettes, break areas, conference rooms, breakout rooms, and a lactation room.
Comfort and environmental quality is a priority for the Learning Center's occupants. Inspired by biophilic design principles, we take advantage of natural daylight patterns to provide an optimal interior environment. Daylight factors, including time of day, glare, heat gain, and visibility, were modeled for the design of 2 distinct types of spaces, task-oriented and non-task-oriented. Within task-oriented spaces, an open floor plan combined with natural daylight strategies facilitates an improved daylight factor. This increases environmental quality and reduces the need for artificial lighting. Where supplemental lighting fixtures are necessary, efficient LEDs are installed with motion sensor systems to reduce wasted energy. Acoustic quality is achieved with 3 design strategies. First, quadratic residue diffusers in the form of ceiling and wall panels diffuse ambient sounds and absorb acoustic reverberations. Second, acoustic partitions between working spaces in the open office will ensure a comfortable environment for phone calls and conversations, while our recycled carpet acts as a natural acoustic absorber to ambient noise. And third, the mechanical systems in the south wing operate virtually silent by incorporating a low-velocity displacement ventilation system and a hydronic radiant heated floor. Our engineering systems are designed to achieve ambitious sustainability goals. The enclosure system of the EcoPark Learning Center includes a green roof, structural CLT, and stabilized earth block veneer. The first component, the green roof, provides thermal mass that collects heat throughout the day and regulates roof temperature to reduce energy loss. Below the green roof are additional layers, such as an R40 XPS insulation, that reduces heat loss through the roof. The second component, the CLT wall system, adds thermal mass to the vertical enclosure and allows for continuous insulation. Using R33 rock wool in the wall supports our pursuit of a low embodied energy building while maintaining a strong thermal insulation. We studied the embodied energy of the enclosure materials and ultimately selected stabilized earth blocks as an architectural veneer because it possesses nearly a third of the embodied energy of standard brick veneer. Our mechanical systems use 3 major components that provide excellent control of the interior environment. In the south wing's assembly room, A hydronic radiant heating loop warms the space through the floor, reducing acoustic interference during events. For cooling, a displacement ventilation system with an integrated economizer can utilize either outside or return air to condition the space, depending on outdoor conditions. The displacement ventilation air handler also utilizes a heat recovery process between exhaust and fresh air intake ducts, reducing energy demand for ventilation in the south wing. In the north wing, where offices are located, a 4-pipe hydronic FCU system provides every occupant with flexibility to adjust their local climate. Occupants can modify each of 17 thermal zones designated within the building from their thermostat. Ventilation for these zones is provided through a dedicated outdoor air system with an integrated energy recovery wheel.
Water interdependence is an important pursuit of the Eco Park Learning Center, which is completely supplied by a rainwater collection and purification system by rainflow. The Learning Center requires 50,000 gallons less water than a typical office building of the same size, made possible with a composting toilet system. To ensure easy maintenance to vertical chases, we have centralized and stacked plumbing fixtures and mechanical spaces. All horizontal runs are exposed overhead to allow for simple maintenance and easy reconfiguration. To increase energy efficiency in the potable supply system, instantaneous hot water heaters are installed on 3 sinks, which heat supply water right at the source, allowing us to reduce long hot water supply runs.
We have ensured that the building operations are smart, efficient, and responsive. The Eco Park Learning Center's building management system is designed to balance comfort and efficiency. Sensors for occupancy status, temperature, and light levels allow the HVAC system, electrical system, and artificial lights to direct resources where they're needed. With watt stoppers, we can save over 10% of annual energy through the management of dormant plug loads and lights. One of our missions at the Learning Center is to demonstrate the building's sustainable technologies to visitors. We introduce an interactive smart wall to display current energy production and energy use around the building. Data tracking and live updates allow users to compare daily, weekly, monthly, and annual energy data to any time period in the building's lifespan.
We achieve excellent energy performance with the integration of both active and passive systems. One of our design solutions involves retrofitting an existing parking lot with an overhead structure with a customized 110 kilowatt PV array. As a side benefit, this system reduces secondary CO2 emissions by cooling the temperature of parked cars under the structure. For this application, we chose SunPower's Maxeon Gen 5 commercial solar panels. In addition to leading the industry in power density, their panels feature a durable design that reduces potential damage. This is especially important in our location at a landfill where dust and debris can be picked up by winds. Our building's efficiency goals are partially met with passive strategies that capitalize on the wooded location of the site. We quantified these benefits with an online modeling software from the USDA called iTree Design. iTree helped us to determine which trees are most important to preserve during construction. Our optimized tree placement model predicts total energy savings of more than 7,000 kilowatt hours, reducing utility costs by around $1,700 annually. Our energy model was developed with OpenStudio. The first iteration of our model, which consisted of 10 thermal zones with ideal air loads, was based on 2009 ASHRAE standard construction sets. This resulted in a source EUI of 92.5 kilobtu per square foot. This first iteration represented our baseline reference model. The second iteration applied an efficient 4-pipe fan coil unit system to our model, which consisted of 17 different thermal zones. Net zero energy design loads and profiles and schedules were applied to this model, which resulted in a source EUI of 41.3 kilobtu per square foot. Our third and final iteration improved the enclosure system with an R33 wall and R40 roof, as well as an R10 slab. This reduced our site energy demand by 18.8% and brought our source EUI to 39.5 kilobtu per square foot.
Our resiliency strategy hinges on 4 critical measures of protection: the building envelope, site resiliency, food production, and rainwater harvesting. the building envelope's continuous thermal and vapor layers ensure that moisture is effectively managed to promote longevity. A German code compliance tool called Ubicus allowed us to compare initial construction options and identify possible issues with interstitial condensation. We then evaluated our final design with a WUFI analysis, which showed some increase of moisture in the winter months, but balanced out with sufficient drying potential in the summer months. Building placement was carefully considered to minimize potential flooding hazards. This is especially important in light of worsening hurricanes due to climate change and our location near the Potomac River. We sited the building in FEMA Flood Zone X, the lowest risk zone, on top of a hill and near a wetland. The hydrologic functions of the wetland lower the flooding risk even further. Local food production is important in the event of a supply chain disruption, which is why urban agriculture is required for the place pedal of the Living Building Challenge. At the Eco Park Learning Center, there are 1,000 square feet of growing beds producing 500 pounds of produce per year. These growing beds are fertilized with compost harvested from the building's composting toilets, tying into the narrative of responsible waste management. Finally, rainwater harvesting contributes to self-sufficiency and is necessary to achieve the water pedal of the Living Building Challenge. Each year, we are able to capture over 316,000 gallons of rainwater. One cistern stores water for green roof irrigation, and another smaller cistern stores water that is fed through our rainflow purification system and directed to potable use. Annually, about 125,000 gallons of water will be available for domestic potable uses.
We believe that the Eco Park Learning Center has excellent market potential. The building was designed to meet an express need by Prince William County. While fulfilling the municipality's needs, we provided rentable co-working space, something that is currently lacking in the region. This state-of-the-art building, associated with an extraordinary environmental enterprise, is fit to attract other municipalities, sustainable tech startups, and waste management companies. There are also opportunities for various universities and research groups to secure residency in the space to operate the labs. Office space is available by the desk, and tenants will have access to amenities provided by the building as well as the park-like surroundings. Financial feasibility is important to provide Prince William County with a realistic vision. We performed multiple cost-benefit analyses to inform the Learning Center's design. Ultimately, our construction budget ended up at just over $10.4 million. This comes to roughly $330 per square foot. Our HVAC and glazing system have a higher installation cost than standard elements, but drastically reduce the overall operation and maintenance cost. Additionally, our building position and roof overhang helps manage our solar gains. The implementation of a solar array and rainwater harvesting system allows us to reduce our annual energy and water costs down to zero. Once we calculated our final construction cost and compared it to traditional methods, we concluded that the cost premium is justifiable due to the long-term energy and water savings. Our energy consumption is 1/5 of a typically built office building. Our solar array allows us to cover all of our energy demand and generate a surplus of energy, giving us the potential to earn over $1,000 annually on our excess production. With the additional rentable workspace at the Learning Center, we can generate income to help offset the costs needed to finance the building. We performed the pro forma analysis and determined that maintaining 80% occupancy of the rentable space can cover 45% of our operational and maintenance costs. Rentable space includes the large gathering area, which is equipped with a catering kitchen, 3 multipurpose rooms that are set up to engage students in STEM programs and help facilitate indoor-outdoor education. Additionally, there are various open and closed office spaces that provide access to a variety of office amenities.
Our innovations are generated from a pool of diverse knowledge brought by our interdisciplinary team. Responsible materials form an important piece of our building's didactic value and true environmental sustainability. Biophilic materials are a very important pursuit for us, enhancing the building occupants' experience in the space. These materials are locally sourced, recycled, and reclaimed whenever possible. Our material selection was heavily influenced by their respective embodied energy. Many of these materials are equatable in durability and strength, excluding cost. While these materials may cost more, the reduction on environmental impact is imperative to our design. Material choice also expresses itself in the landscape design, such as recycled concrete chunks and recycled glass pavers. Excavated soil from construction will be stored on site to engage school children in the simple production of compressed earth blocks. These blocks can be engraved with student names and built into seating spaces along the woodland trails. These materials will serve as talking points on tours and build the narrative of sustainable waste management into the Learning Center's physical body. Another one of our innovations uses strategic site planning to preserve a tributary of Powell's Creek. This stream, which runs through the middle of the landfill property, is currently considered for piping by Prince William County in order to eliminate the floodplain and provide more space for landfilling. We are aware that floodplain soils hold large amounts of carbon, so we aligned one of our bike trails along the stream to provide an incentive to preserve it.
To conclude this presentation, we want to cycle back to our design goals. The 4 C's of conservation, community, comfort, and cost awareness are chosen to respond to the needs of every stakeholder in this project. These include the local ecology, the people of Prince William County, the occupants of the Learning Center, and the municipality. It is important to us that all living systems are winners in this process. This ambitious design philosophy led us to push for Living Building Challenge PETAL certifications. We went above and beyond the client's expectations and designed outside the bounds, bringing the mission of the Eco Park into the entire landfill master plan. And this brings us to our ultimate vision. Across the globe, we have seen in recent decades the transformation of decommissioned landfills into valuable public land. Examples such as Mount Trashmore in Virginia Beach, Huria Park in Israel, Fresh Kills Park on Staten Island, and many, many more serve as inspiration for what these industrial sites can become after their operational life. Prince William County landfill is estimated to have all of its mounds filled and capped by 2060, but the Eco Park Learning Center is built to last far beyond this date. We hope that the groundwork laid by our Eco Park Master Plan will activate a repurposing effort for the Learning Center, so that it may become the cornerstone of this region's most spectacular public park. This final act of recycling will complete the narrative. We are Team Compositive, and we thank you for listening.
We did it.